And good morning, good afternoon, or good evening. This is the Antrea community meeting, and today is Wednesday, the 6th of July. Of course, as usual, if you're in the United States, it's still Tuesday, July the 5th. This meeting has been moved by 24 hours from the original schedule to take into account for Independence Day in the United States. And for today, we have a presentation about multi network policy enforcement in multi-cluster scenarios. We know that we already have replicated network policies in these scenarios. In this case, we are talking about a use case for policies which are stretched among clusters, which means where the criteria of the network policies can select pods which are in different clusters. But since I am probably the least qualified person here to talk about this feature, I will let Grayson go ahead with the presentation. This is a feature that has been worked so far by Grayson and Yang, with quite a bit of help from LAN for whatever concerns the multi-cluster deployment. So Grayson, please go ahead.
Okay, thanks for the introduction, Salvatore. Let me share my screen. Can you guys see my screen?
Yep.
Okay. Okay, hi guys, I'm Grayson. Today I'm gonna introduce the stretched Antrea native policy, and Yang and I will go through the whole design of it. So this is today's agenda. First, the background. We're going to introduce our current state, why we need stretched Antrea native policy, and then go to the label identity, which is required by the stretched network policy to do the matching, and then the implementation of the stretched network policy. And also I have a demo video to show. And the first, I will let Yang to start. Yang, we can't hear you.
Sorry, can you guys hear me now?
Yes, we can.
Okay, yeah, so, sorry about that. It's there's some issues with the computer speakers. So I'll just quickly go over the background for the stretched network policy and the label identity design. In terms of the background, in our current upstream Antrea multi-cluster service capabilities, we already have a lot of features that are in the multi-cluster space, which first and foremost includes service export and import. This means that we are implementing the upstream and multi-cluster service API, and for a bunch of clusters, if they are having similar, they're managed by common admins or whatnot, they can form a cluster set, and some services in one cluster can be exported to the cluster set. So every cluster in the same cluster set can access the exported service. And this is the very basic part of the MCS API. And then on top of that, we have ACMP first supporting 2 services for multi-cluster services, which means that in a single cluster, if you say, I wanted to allow, deny, or reject traffic to a specific multi-cluster service, this can be done in a single cluster. But the apply to will only be workloads in the cluster which the ACMP is created. And then after that, we added a capability called ACMP replication, which means that for a same ACMP, you can replicate it across all the clusters in the cluster set. So with those 2 capabilities combined, we already have a really complete egress control for workloads towards multi-cluster services without having to, really introduce anything specific for multi-cluster services. However, this, as I mentioned in the limitation, this is not the case for ingress, right? So thinking about if you wanted to restrict access towards a multi-cluster service endpoint, when you wanted to specify ingress peers, you needed to specify whether this ingress peer is only concerning the workloads that initiate traffic to the service from the cluster itself, or it can be, a lot of other paths from other cluster in the cluster set. This requires us to have like new APIs and new stretched network policy to make the ingress multi-cluster policy enforcement possible. So this is the background on why we actually needed the stretched network policy and why it is only sufficient if we introduce it from the ingress side. We can go to the next slide. Now we wanted to talk about what is label identity and the concept behind it. So why label identity? Let's just imagine that we wanted to write a policy which selects some backends of the multi-cluster service, and then we wanted to restrict ingress from pods that are either in the same cluster or from another cluster. A naive idea will be just to use the when we have such policy, we'll just compute all the IPs of the selected workloads, either it's in the cluster or from another cluster. And we just use the IPs to program OVS rules like we do for the network policies. The problem is that for multi-cluster service accessing, LAN has added a great feature, which is having gateways for each multi-cluster, for each cluster in the cluster set. And there is actually SNET happenings for this traffic that's across clusters. Now, these SNETing makes the original IP unknown to the destination cluster. So this is the first challenge we have if we wanted to just simply enforce policies based on IP. And the second challenge is that in order for us to use IP to enforce this kind of network policies, each cluster in the cluster set will have to know the IPs of all the different pods in different clusters in order to use the policy label selectors and translate those into the IPs that these selectors actually select. And to sync these IP informations in the inter-cluster set is not scalable at all, because the IPs are can come and go, right? So the pod IPs are very ephemeral. They can change, and for deployments, scale up and scale down, these IPs add and they're destroyed pretty quickly. So there's going to be a lot of churn in terms of syncing these informations in the inter-cluster set. So the solution we came up with to resolve this issue is the thing called label identity. Instead of needing to know the IPs of all the pods, we just needed to sync the information about the pod labels across the cluster set. So the idea is that each cluster in the cluster set will know what kind of pod or namespace labels that exist in the cluster. And then when a traffic comes from out of the cluster, it will carry information of its originating pods labels, so that we can use the identity or ID that are carried in the packet to enforce policies on the destination end. So this is the idea for label identity. And we have listed two alternatives we have considered for the actual form of the label identity. The first alternative is that we have a long label identity for each pod, not for each pod, but for each pod in for each deployment, I should say, basically. And the label identity will include the information of the namespace of the pod, which includes all the labels in that specific namespace, and also the pods labels. And we concatenated them into a single label identity. So as you can see, if we have a namespace which has labels in equals prod, maybe just call it production in, namespace, and we have two types of deployments in that namespace, and one is app equals to client and the other is app equals to DB, then we will have two different kinds of label identities. And we can use this label identity to we can encode this label identity in the sending side and enforce policies for this label identity on the receiving side. And the other alternative is that we separate the namespace and pod label identities. This can potentially reduce data exchange because we kind of like decouple the namespace label identities and the pod label identities. So for the above example, for names label identity, we just have one identity, which is env equals prod. And for the pod label identities, we have two. So even though that there are three label identities we needed to sync in this bare bones example, but as you can imagine in real world, if you have multiple namespaces with different labels, and each of the namespaces only have pod app equals client and pod app equals DB, then decoupling those two will significantly reduce the number of label identities we needed to sync across cluster set. So this is the idea on, maybe we can separate these. With these two label identities separated, we will have a little bit more complicated logic in terms of enforcing these or computing the label identity selected by a policy and enforcing this in OVS. But we think that separating these will be a better solution as of now, even though that for the first round of implementation, we were using alternative 1 instead of alternative 2. So in a demo video that Grayson is going to show later today, it will also be using the alternative 1 name label identity format, but we're looking to change the label identity format to the latter. I'll pause here in case there's any questions so far.
I want to add some details for the bit usage thing. Like if we use separate labels, so we have to assign separate bits for namespace label identity and the pod label identity. For example, if we have 24 bits in total, then if we assign 12 bits for the namespace label identity and 12 bits for the pod label identity, then the pod label identity only will have less than 5,000 available. This it's kind of risk that it will not be enough. And if we go, for example, 8 and 16, then the namespace label identity probably will not be enough. But if we use combine label identity, which means just one ID, we have 24 bits, which although we're gonna use much IDs, but there will be more available IDs if we combine them. Yeah, this for the bit usage thing. And for the data exchange, probably there would be a example like there's the one namespace and 100 pod inside it. And when the namespace changed its labels, if we separate it, we only have to do the resource export import for the namespace identity instead of do 100 combination label identities, I think. Yeah,
thanks.
This is, just some details.
Thanks for this. And Grayson, I would imagine you need to bring up your first point again when we actually talked about we wanted to encode the label identity into the Geneva header, because we don't have any, so right now we haven't introduced this yet, so it might be a little bit confusing for people who doesn't know this, but
I'm gonna bring it back when I go to the data path implementation. Yeah.
Right. Thank you.
Yeah.
So if there's no other questions, I guess I'll just move along to the next part. Can we get the next slide, please? Thank you. So this is the sort of like life cycle diagram for the label identity replication across all the clusters. For people who are familiar with multi-cluster resource exchange pipelines, this is a really familiar diagram, and we actually also use this the regular resource import and export pipeline, which is already existing in the multi-cluster to implement the label identity replication. So the idea is that in each of the member cluster, there is a exporter that is watching for pod and namespace label events. So let's say there's a new namespace created or a bunch of new pods created in those namespaces. Those are all qualifying events for the exporter in the member cluster to say, hey, we have a new label identity in this cluster. Now we needed to wrap this label identity in a resource export and create this resource export to let the leader cluster know that we have new label identities in this member cluster. And what the leader cluster does is that it consolidates all the resource export information from all the member clusters regarding the label identities. And it also does some deduplication, because multiple member clusters can have the same label identities because it would just be namespace labels and pod labels. So when that happens, it is only we only needed to assign a ID for each unique label identity, and for this unique label identity in the cluster set and the ID mapping, the leader cluster will actually create a resource import so that each importer in the member cluster can watch this resource and actually create the label identities in their own clusters. So with the entire loop, after the entire loop, the outcome should be each member cluster will have the idea of what label identities that exist in the entire cluster set. Plus, for each of the label identities, there should also be an ID associated with it, and the label identity and ID mapping should be exactly the same across all member clusters. This is how, if a packet is sent out from one member cluster and received from the other member cluster, and it has the ID, let's say 2, then the receiving end will know that, oh, for the original packet, it is sent out by a pod which has label blah blah blah, and the namespace will also have a label blah blah blah, because it can use the ID to look up from the local mapping and understand what the label identity was originally. And yeah, let's go ahead to the next slide. Right, so this is some of the really high-level API changes for the resource export, in addition to the service export, ACMP export, or external entity export or whatnot. We're adding a new type, which is label identity export. And for here, if we're using the alternative 2 we just mentioned, then for the label identity export, we will export the normalized pod labels and normalized namespace labels of a specific cluster and export it to the leader. And yeah, so for the first 3 bullet points, this is the entire life cycle I just mentioned from the diagram we just saw. And this is also a example on what these label identities will look like. As you can see here, we have 2 namespaces. The 2 namespaces have 2 different labels for the namespace themselves. And one namespace A will have a deployment, with a replica of 2. And for the namespace B, there's also a app equals client pod, and there's a app equals client level equals a min pod. In this specific case, if we're using alternative 1, we will have 3 different label identities. Essentially, each pod label and namespace label combination will have a unique label identity and a ID assigned to the label identity. Or we can use alternative 2 so that each unique namespace label set will have a unique label identity, and each unique pod label identity will have a unique ID. So both of them are really similar, but in their ideas, it's just that the label identity format will be slightly different. And I guess I'll just skip this for now. Oh, sorry, I'll not skip this because we also had the 2 alternatives in terms of label identity importing, but we did decide on using the first alternative, which is that for the label identity imported into each member cluster, we'll create an object for each label and ID pair. So the result is that in the importing member cluster, we will have a label identity object for each of the label identities. And we didn't want to do an entire map of all the label identity that exists. It's because that if there's any label identity add or update events, it will cause the entire object to be updated, and for each of the member cluster, they will receive a huge update, and needed to figure out what's the update to the label identities, and which we thought will be bad. So essentially, after all this resource exchange pipeline is done, each member cluster will have a label identity object for each of the label ID pair. And also, we will, if we are going with the alternative 2, which is separating the namespace and pod labels, we will also have a resource type or resource name for the label identity import spec, which signals that if whether this label identity is for namespace labels or pod labels.
Hey, I have a question.
Yep.
And how will we name the resource export and the resource import? The object name will be hashed from the label or something?
That's a good question. So for the resource export, we actually just have 1 resource export per cluster, so that when leader receives it, it knows that, okay, we are talking about the resource export for, we're talking about all the label identities that's in cluster A or cluster B. So there's a predefined name for the resource export for that cluster. And for the resource import, the name is a hash based on the label identity.
You mean the resource export is one object per cluster, which
Right.
contains all current labels. But does it have the same problem as the alternative tool of label identity import? That whenever a port is created, if it has a new label, the whole labels of this cluster will be exchanged with with the common error, the export API once, right? If there are like thousands of deployments in this cluster, then an object with thousands of labels, I'm not sure the size of the object, but will it be a performance concern?
That's a good question. Let me think about it a little bit on why we did not.
I'm not sure whether there will be a security the performance issue. I thought it has the same issue as the alternative tool of import resource, right? If we concern the performance of the alternative tool of import, why we still use same approach for the export resource?
So I vaguely remember there was a concern on let me try to think about this. I vaguely remember there's a concern on maybe racing between different clusters. It's because that if you consider this, if there are two clusters that are receiving a label identity, the same label identity, which they wanted to update to the leader cluster at the same time, and if we don't do a resource export per cluster, instead we do a resource export based on the label identity itself, then the two different clusters which have the same labels might be, trying to update or delete the same resource export at the same time. So I would imagine that by the time we designed it, it will be a sort of like a racing concern. In the current design, each of the member cluster will only be, performing on the resource export on its own cluster. So we can easily manage the race there. But if we are using the other way, then there's this racing concern, because it doesn't really apply to the resource import, because the leader cluster will be the only one updating these resource imports. Does that make sense? I need to think more clearly on why we did that, or maybe we can improve this by doing the same for the export. But I believe that was the reason why we didn't went with it.
I see. I think if race condition is the concern, and we address this by even with current approach, I think we just use different name. For example, for cluster A, I think you will have some kind of prefix or suffix having the cluster information as a resource name of export, right? Then perhaps the suffix or prefix could also be used as per label export object name, right? For example, from this cluster, even it's same labels as another one, it will has a different name, so that they won't conflict. but I'm just curious why we use the different approach. I'm not saying there will must be performance issue. Let's see if the issue really exists first.
Yeah, sure. Thanks.
I do feel it's not very efficient to have a single object for all the labels, right? Because the object can be pretty big if you have many label convolutions in your cluster. And then when you watch object, you have to, even it's a single label change, you have to watch the whole object with all the labels.
Yes, that sounds not very efficient. And according to the implementation of the storage etcd, I think it will keep a copy of each version of the object. So even you insert, I'm not sure how many replicas, how many versions it will keep, but I think even a single single update, an update to a single label, it will cause the whole object to be copied once and stored in the storage until it's garbage collected.
I see. I agree. This is something I haven't revisited, I guess, after the design. So we probably wanted to consider using a single resource export for each unique label identity for the exporting process as well. We will, Grace and I guess we'll follow up on this. Thanks for the suggestion.
Thanks. That's a good catch. There any other questions?
I think you can go ahead.
Okay. Yeah, I'll take over from here. To go with label identity data path implementation. We also have two alternatives here. First one is leverage the Geneva header TLV. So we load the path label identity into the register in pod classifier flow. This is where the label identity go into the pipeline, and then we use the Geneva header TLV to carry this label identity across node and the cluster. As you can see below, we got an initial TLV map. We can define our class and type, and choose metadata to use for the label identity. And there are some change in our pipeline. Like the first in the classifier table, for each pod, we're gonna add an action to load the label identity into the register. For example, we use the let's see, we go with the separate label ID. We use the first 16 bits for namespace label. We load the namespace label in the first 16 bits, and we load the pod label ID into the last 16 bits. So then the label identity of this pod is inside the register, and if the traffic is let me go to the last one first. So when the packet is leave this pipeline in the table output, it will move the data in the register 10 into the tunnel metadata 1, which is we chose in the TLV map. So in this way, the new TLV map will map this data in the metadata 1 into the header variable length options, and at the target node, it will do the reverse thing, and the traffic will go into the pipeline through the tunnel interface. And let's see the second flow. In the classifier flow, if the data is from the tunnel, we will unload the data from the tunnel metadata into the register where we used to store the label identities. Here is a kind of traffic path for better understand. This is the most complicated case, like a regular node on cluster A want to talk to another regular node on cluster B. As we can see on the very left, the pod A send out the traffic, and the first in the classifier flow, we know, oh, it's from a pod. So we load the label ID into the register, and then we arrive the output table. We move the register data into the tunnel metadata, and the Geneva TLV map do the job to map the data into the variable length options. And then it arrive the gateway node. First, the Geneva TLV map would do the reverse thing. So the data is now in the tunnel metadata and in classifier flow. Since it's from the tunnel, we unload the tunnel metadata into the register. And oh, by the way, during the whole pipeline, if some place the network policy will be enforced, it can use the register data, which is a label ID, to enforce. Yeah, so went to the output table, do the same thing, and then go to the cluster B gateway node, which have the same pipeline as the gateway on the cluster A, and then finally arrive the regular node on the cluster B. So it's also from the tunnel, and the tunnel metadata moved into the register. So now the register contains the label identity of the pod A in cluster A regular node. So we can use this label ID in the register to enforce the network policy. Probably will be inside the Antrea ingress rule table here. So yeah, this is the alternative one to use the Geneva header TLV map. And the alternative two, we're gonna leverage the VNI. This is much simpler on the implementation. All we need is still on the pod classifier flow, we load the pod label identity into the VNI, which is a set the tunnel. And after this action, the label identity will go with this packet until the end. So we could use the tunnel ID, the VNI, whenever we want to enforce the network policy. Also, it could save the bandwidth since the VNI is already carried by the packet. We just haven't used it. So in this way, we no need to change the MTU. Since if we're gonna use a TLV solution, we have to change our MTU. The packet will be bigger than before. The cons will be the VNI only have 24 bits. So as I said before, probably we can't separate the namespace and the pod labels, since if we separate to 12.12 or 8.16, they all have some risk to be not enough. And other cons is I'm not sure if this field will be used by other purpose in the future, since it's kind of like a network identifier. Currently, it should be fine. We don't use it in Antrea, but yeah, and this is the two alternative for the data path. Does anyone have some comments or ideas?
Grayson, do you think that changing the MTU, increasing the MTU to take into account of the larger packet could be a problem in some real deployment scenario, or it should be generally okay because it's just for for the Antrea pods?
I think this I discussed this with Jian Jun before. He mentioned a scenario like if a user, for example, start Antrea, but haven't enabled the multi-cluster feature, since if we to save the bandwidth, if the multi-cluster feature was not enabled, we don't change the MTU. But if the user set up the Antrea and then enable the multi-cluster feature gate, probably we have to like restart the all agent or all paths. So this sounds like kind of weird, I guess.
Did you say restarting the agents and then restarting also all pods?
Since all the since the MTU has changed, all related components should to make the change corresponding to this.
I see. Yeah, I understand, because we need to recreate the network interfaces for the pods.
Yeah. So
if sorry, I
go-
have a question. So if a pod is, for example, it doesn't use any multiple cluster service, but does the pod will also be affected if we have to change the MTU of our pods?
if the multi-cluster feature or stress network policy have its own feature gate, if this is on, we have to change the MTU since all pods will carry the label identity with it.
Yeah.
Yeah.
I mean, even after we enable the feature, and then not all of the pods has to use the multi-cluster service, and then actually inside each cluster, the normal traffic will also be affected by the change of the MTU, right?
Yes, since we are not sure if a pod will use the MC service or not. Yeah.
Got it.
Yeah, I personally feel using WinI not that bad in my mind. Anyway, in Antrea network, we don't use that field today. I think set to wall 0 today. And potentially, if you believe that some other service will look at the traffic, I think mostly they will not look at the WinI field in my mind. Because that is mostly for the layer 2 switching to identify layer 2 network.
Okay, so so what do you think about the separate or combine the labels? Since if we choose VNI, probably we have to choose the like one ID combine the
Yeah,
name
I don't have a strong opinion on that one. Yeah,
Okay.
I also wonder which way is your preference.
Actually, this is kind of related to the how we're gonna implement the label identity export. If it's a whole a complete map of the all label identity inside this cluster, if this is case, I guess maybe if we combine them to a single ID, it should be fine since the data exchange won't be that different. If it's like each ID have a single object, then the difference will be huge. Which is like the example I said before. Yeah, the namespace contain 100 pods one. Yeah.
I think probably we will not have a single object for all the labels in my mind. Probably we need to create the object per ID.
I'm sorry.
I think for export and import, in my mind, we should create a resource per ID, not a
Okay.
single resource per cluster.
Okay. If this is the case, maybe separate them will save the data exchange. If the namespace update is a label, we only just do the resource export for this namespace label identity instead of all paths inside it.
Yeah, that is true. But I think that
Yeah.
the implementation sounds more complicated.
Yeah, that's also true.
Yeah, I don't know.
Yeah.
It's a little hard to make a trade-off here.
Okay.
By the way, Cilian also encodes the ID into the packet, right? I think in their case, they are doing some even tricky thing in my mind. They actually differentiate is TCP or UDP. If it's TCP, they encode ID into the first SYN packet, I believe. Since the SYN packet is very small, so you can always assume you can append quite some bits there.
Okay.
For UDP, I forgot for UDP what do they do. I'm not sure they.
So basically, it's trickier than we use the VNI to store the label identity.
Yeah.
Right. Yeah. Okay.
And I told you, I know some solution even you reversed bits. For example, I know NSSV and I believe the Silk from Pivotal, basically the Cloud Foundry also use some reserved bits of Western.
They encode the. I think that they encoded the network policy identifier into the VNI header. They encoded they encoded an identifier, a unique identifier for the network policy in the header. But in that case, it's slightly different because they're in single cluster.
Okay.
Okay. There's not too much time left. Maybe we could discuss this more offline.
Yep.
Yeah.
I agree.
Sure.
Yeah. So for the stretch network policy on the API wise, there are also two alternatives. First is we add a scope field, like the policy on the left, to our current Antrea network policy. So basically, after this field is added, the policy on the left will work like it will apply to all pods in the namespace prod US West, which match the label app equals DB. This is same as the single cluster work. For this one, it will allow all traffic from all pods in the namespace prod US West from all clusters in the cluster set. And if this namespace exists in that cluster and whose label match the app equals client and deny all other traffic. So to use this alternative to as the stretch network policy API, the advantage is we can reuse our current implementation. Like we can reuse the controller and the whole priority module. And the challenge of this one is the Antrea native policy will be more complicated, like more special flags. Since this is another like special flags for the scope of this this peer. And the other alternative is we create a new CRD, for example, called a multi-cluster access policy. This is works exactly the same as before. They apply to and the ingress from. Only difference is it will work in a cluster set scope. The advantage of this thing is since it's a new CRD, it's a self-contained and independent API types controllers. So it will reduce the our Antrea native policy current special flags number. And we can also, since the purpose we're gonna use the stretch network policy is to secure the ingress of a service. So we could make the apply to only can be a service reference here. And we can also only allow the ingress rule here, since this is what it's for. But the key challenge of this is that it's really hard to either reason about or visualize the relative priority compared to the our Antrea network policy or cluster network policy. So according to this, our current implementation is using the alternative one, since the priority things it's quite tricky. Yeah. So on the controller, the controller will watches the label identity CRD, and then update its cat. Sorry.
No, sorry, Grayson, there was a noise from me, but it was not meant for this meeting. Sorry, it was an accidental noise. Sorry about that.
Okay. Update its cache. And the controller will process the Antrea policy into an internal MP using its cache. Basically, it will translate the selector to the label identity. So in this case, we will add the label identity field in the network policy peer in internal MP, and the label identity peer looks like below is contains one pod label ID and the namespace label ID. If we combine them, then here will be only one ID. So here's an example how the controller translated a policy like the left. It select the like pod selector app equals client and the namespace selector environment equals dev, or the pod selector level equals user. And this is the current label identity imported in this cluster. So a internal network policy like the right will be created. So it's first the label ID is 2, which is app equals client, and the namespace ID is 1, which is environment and is equals development, and the other is the label, only the label ID equals 1. So after the internal network policy was created, then the works go to the agent. First, the agent will also watch is the label identity CRD and update its own cache. Also, the agent will watch the pod label update event to update its classifier flow using its cache, since the pod classifier flow gonna load the label identity into the register or the tunnel ID of VNI. So it's also need the label identity cache. And the last thing, the agent is gonna install OF flows according to the internal network policy. One thing to mention is besides we install the flows for the network policy rule, we're gonna also install a set of security flows for each rule. Here's an example to show you how the flows look like and how the security conjunction looks like. The left is the internal network policy. So first, the normal conjunction will be like here, like the register 10, the first 16 bits equals to 2, and the last 16 bits equals to 2, and the first 16 bits equals to 1, which match the first label identity. And the other thing is only the last 16 bits equals to 1, which match the label ID is 1. This is a normal conjunction. And we also have a security conjunction. So why we need this is because when the pod update is label, if it's changed to a completely new label combination, which is new to the whole cluster set, then the leader cluster have to assign a new label ID to this label combination. So when the label update its classifier flow, probably the new label ID haven't been sent back to the to the agent. So to avoid the pod will completely lose the connection, it will install the pod classifier flow with a label ID 0, which we define it is a unknown label ID. So when the new ID arrive back to the agent, we're gonna update the classifier flow with the new ID. But during this time, all traffic come out from this pod will carry the label 0. And we have to make sure our stretch network policy will not allow those unknown ID pods traffic. So we install this security conjunction, which will match the label identity is 0, and we're gonna do an arbitrary drop for those traffic. And yeah, this will be just to in case if the pod will carry the unknown label. But this will be a kind of rare case, since I haven't do any benchmark or skill test, but currently the new label ID speed is the gap is small. And I don't have too much time. Do you think I can show the demo video or?
Shouldn't be a problem if you can do it in 2 or 3 minutes. I mean,
okay. If this is the case, I just show the last part of this.
Yeah.
This video. Let me see. Okay, so now the so upside on the downside, there's a stretched network policy. It's select the pod app equals client, and the scope is a cluster set. And after we apply this stretched network policy, and okay, the traffic is blocked. Maybe this one is boring. Let's see. Maybe we show the maybe show this one. We create some pod and namespace on the cluster A, and downside on the cluster B. You can see the label identity has been successfully imported. This we use the combination pod and the namespace pods, the namespace label and the pod label, and the ID is 5. And on the upside, we can see the pod will load its label identity into the register 10. Yeah. So this is downside is stretch network policy, how it's gonna match the traffic. It will like match the register 10 equals to 5 or 7. This is label ID to enforce the network policy. Yeah, it's a quite hurry.
And the security flows that you mentioned, they are in a different table, right?
The security flow I haven't included in this demo.
Got it.
Yeah. Yeah, that's all. Thank you guys.
Thanks.
That's a really long
Thanks,
time.
Grayson. Janjun is reporting a comment on the chat. It says that another idea is to support filters to filter labels to export on import, assuming users will just use a small subset of labels for stretched policies, which I believe means that it will be sort of a compromise between the approach of exporting labels one by one and the approach of exporting all the labels at the same time. So that's another idea that we can consider.
Mm-hmm. Okay.
All right, we are already over time, so I would like to thank a lot Grayson and Yang for this great presentation and this nice demo, even if we had to shorten the demo just to 3 minutes. Is there any final question for Grayson and or Yang? Okay, my only comment that we can revise also in other meetings is that you initially you said that you have two different alternatives for for having for the style of the label, let's say, and then that eventually you wanted to move from alternative 1 to alternative 2. And when doing so, we probably just want to consider the upgrade implications to see if there would be any issue during upgrade, but that's something that we can discuss in a separate we don't need to discuss it now. Okay, I will just wait a few seconds to see if anyone has any other question. Otherwise, we can conclude the meeting. All right, it seems that there are no more questions. So thanks again, Grayson and Yang. Great presentation. And I would like to wish everyone a good night, good morning, or a good afternoon. Thanks again for joining. And the next instance of the Antrea community meeting will be back on Tuesday, July the 19th. Thanks a lot again and have a good one.
Thank you, guys.